All right, welcome back, everyone. Today we're going to talk about systems of equations with three or more variables. We're really going to focus just on three variables. We're going to learn how to determine if a given ordered triple is a solution to a system of equations, and then how to solve a system of equations with more than two variables. So to determine if a given ordered triple, okay, so now we're talking about systems with more than two variables, so it's three variables, x, y, and z. If we want to determine if an ordered triple is a solution, we're just going to plug in x, y, and z and check that both sides are equal. And it should work for every equation. If 2 out of 3 works, then it's not a solution. It has to work for all three. So let's start this. Right? The first equation, we have x plus y plus z is equal to 2. We want to determine if the ordered triple 3, negative 2, and 1, so that's x, y, and z, is a solution to the given system. So x is 3, y is negative 2, and z is 1. 3 plus negative 2 is 1. 1 plus 1 is 2. We get 2 equals 2. And the first one's okay. Now let's try the second equation. We have 6x minus 4y plus 5z is equal to 31. So that's 6 times 3 minus 4 times negative 2 plus 5 times 1. 6 times 3 is 18 plus 8 plus 5. 18 plus 8 is 26. 26 plus 5 is 31. And so the second equation works out. We now just have to check the last one. 5x plus 2y plus 2z is equal to 13. Now x is 3. Y is negative 2, and z is 1. 5 times 3 is 15. 2 times negative 2 is negative 4, plus 2. 15 minus 4 is 11, plus 2 is 13. And so the third equation works out. So the given point is a solution. So if you're given the point, just check to make sure it's a solution by just plugging it into each one of the equations. Now, solving the system can be a little more complex. For each variable that we add another equation. And for every equation that we have to add more eliminations. So in this course and for this section, I'm only going to show you how to do a system with three variables using multiple eliminations. If you wanted to do 4 or 5 or 6, you could do the same process, it would just take a lot longer. As you'll see, just going from 2 to 3 makes it take a lot longer. So let's try this example. We want to solve the system of equations and write our answers in ordered triple. When we're solving a system of equations with more than two variables, we have to use elimination. And when we use elimination, we have to use elimination a bunch of times. And so for the first step, we're going to use elimination to get equations with just two variables. So in other words, we're going to eliminate one of them from two sets. So we basically have to pair these things off. Just to make this simpler to understand, it doesn't really matter how you pair them off, so long as you don't use the same pair twice. But to make this simpler to understand, we're going to put the first two together, and we're going to put the first and the third together. And just to simplify things a little more, let's eliminate z first. So we have x plus 6y plus 3z is equal to 4. We'll start with the red one first. 3x minus 2y plus z is equal to 0. So this is our first and third equation, and we want to eliminate z. So to eliminate z, we've just got to multiply by some constant. If we multiply the bottom equation by -3, then what we have is x plus 6y plus 3z is equal to 4. And then -9x plus 6y minus 3z is equal to 0. If we then add straight down, we've now eliminated the z's, and we're left with minus 8x plus 12y equals 4. Hold on to this equation, and we're going to come back to it. We want to do the same type of elimination, except now let's just use the first two equations. And so going to the next page, we get x plus 6y plus 3z is equal to 4. That was our first equation. We're then going to combine that with the second equation, 2x plus y plus 2z is equal to 3. And we want to eliminate z. So let's multiply the top equation by -2 and the bottom equation by +3. What that's going to give is -2x plus -12y plus -6z is equal to -8. 6x plus 3y plus 6z is equal to 9. We add straight down now, the z's go away again. And we're left with 4x plus -9y equals 1. Here's our second equation. Now we've eliminated z by just grouping together the first two equations and then the first and third equations. Now we have two equations in terms of x and y. We're going to eliminate again, this time either x or y, whichever is more convenient. So let's go to our next slide. We've got 4x minus 9y is equal to 1. That was from our last grouping. And from the first grouping, we have -8x plus 12y is equal to 4. And so, in this case, it seems easier to eliminate x. So we'll just multiply the top equation by 2. So that would get 8x minus 18y is equal to 2. -8x plus 12y is equal to 4. Now we can eliminate by adding straight down. We get -6y is equal to 6. Divide by -6 and we get y equals -1. And now that we've got our first value, it's a lot easier to make our way back. Taking y and plugging it into one of these equations, we can get x. So 4x minus 9y is equal to 1. Y is -1. Then we get 4x plus 9 equals 1. Subtract 9 from both sides and we get 4x equals -8. Divide by 4, and now we get x equals -2. And so now if we go all the way back to one of our very first equations, we can solve for z. So x plus 6y plus 3z is equal to 4. And we now know that x is -2, y is -1. That's going to give us -2 plus -6 plus 3z is 4. It's -8 plus 3z equals 4. Add 8 to both sides. We get 3z is equal to 12. If we then divide by 3, we get z equals 4. And so our ordered triple, the solution is going to be the point x, y, and z, which in this case is -2, -1, and 4. So at the end of this lesson, you should be able to determine if a given solution is a solution to a system of equations, and determine the solution to a system of equations with three variables.